Assalamualaikum warahmatullahi wabarakatuh and a very good day to everybody. Now we are continue. I think this one is the last final session for this second chapter, hopefully inshallah. So now we want to have, for example, we have the forces is actually apply to in any particular object or any particular point. So before this, we are using the method of using the parallelogram. So it's actually parallelogram. When you are using this method, is actually the force actually they apply to one object, one of particular point must be at maximum is two. Only two forces. So let's say we have more than two forces. So how we want to draw the parallel or the parallel so called that parallelogram law, how it's actually like a rhombus. How you want to make the rhombus on from these two forces. Let's say we have the more than two forces. We make more than two forces. So we come out this method. So because in order we want to resolve these two forces, resolve these forces, then we after we resolve, we can add and we can get the resultant force. Okay, so now how we want to add the forces that we have, the more than one forces, more than two forces. So actually we can use this method, whereby is the force. For example, we are talking this force is a vector. So for example, this force is subjected an angle from this point to this point. For example, we can take 100 Newton or whatever. So we have the angle. So meaning that this vector have a direction from this point to this point. So from this point, how you want to go for here? So we can travel from here in x direction. This one is from here, and then from here we go to up. So from here to here is actually in x and y axis. From this point we go to the right, and then until this point we go up. Then we reach the final point of the direction of that particular forces. Okay, so meaning that we have the two magnitude or two direction here. So in x component, in x direction and also y direction, in order to go to from here to finally this point. So meaning that these forces we have the angle. So we have the two component, to another two side, additional two direction. We have the from this point to this point and this point to point, because if we add this magnitude and this direction, this is a vector in x direction. If we add this vector in x direction and then we add this vector in y direction, it's actually equal to this vector, because this one is triangle. Fx, the vector in x axis plus the vector in y axis is equal to these forces. So in order that in any other way, we can see here the force we can break up. We can break into the x component and y component. So meaning that the vector force is equal to the force in x component plus then force in y component. So how you want to get the fx and fy? So we can get the fx and fy. So by using the trigonometry here, we have the sine theta and also the cos theta. So by using this relation cos theta, we can get fx, fy is using the f multiplied by f sine theta. Okay. So we can express this one is in the magnitude. We can express the forces in terms of the Cartesian vector notation, whereby the x axis, x direction, the unit vector is unit vector I is for x direction, and the unit vector j is the y direction. So actually the unit vector I and j has the dimensionless magnitude of the 1. So the fx and fy is actually positive quantity. So force is actually the fxi plus fyj. So because we cannot simply add the magnitude, because this is a vector. Okay. So let's say here, for example, I said here we have the more than two forces. We have the first one F1xi plus dengan F1yj. Same thing for the F2, same thing for the F3. So now we want to add all the forces, so we can find the resultant force. We can get all the component of x. F1x plus dengan F2x plus dengan F3x. This one I unit vector, and also the F1y, F2y, F3y. This one is as a G vector, whereby the FRS is the vector in x direction. We are total up all the vectors in x direction, and the FRY is the resultant all the in y direction. We can see, we can notice that y is the F2x a negative, y is F3y is a negative, because we resolving the force respect to the x and y axis. So x is positive in this direction, y is positive in this direction, but F2x is opposite direction. This one is a negative x axis, and then the F3y is a negative y axis. This one is a negative for the y. So that's why we have the negative F2x, negative F3y. Okay, so after we get the resultant, so you can find the magnitude of resultant by using this Pythagorean theorem. So let's say this resultant force, we can find the resultant force by using the Pythagorean theorem. Is Frx square plus and Fry square. Then the product is, and then we can square root the product of these two addition. And then the theta is given by the shift tangent, the Fry dividing by the Frx here. Okay, so we can see the example. For example, we have the two forces acting on the boom. So express each force as a Cartesian vector. So now how I want to express the Cartesian vector? This F1, for example, subjected to 200 and then 30 degree from the x negative. This one is the second quadrant, and then F2 260 Newton by using the angle 5, 12 and 13. So the F1x, so it's actually this one the negative direction for the x-axis. You can see here negative. So 200 multiplied by sine 30, because by the sine 30, this one is the opposite of this angle for x direction. So we can have the negative 100 or positive 100 to the left. And then F1y is 200 multiplied by cos theta. This one we have a cos theta is equal to 173 Newton, or 173 Newton to the up. So the theta is by using the tangent theta, the slope, and then we can get the angle. Okay, so for the F2 we have the F2x and F2y. So by using the relation of the similarity of the triangle, 5, 12, 12 and 13. So F2x is 12, because 12 is x, 12 over 13. So 260 multiplied 12 multiplied by 13. So you get 240 for the component x. And then now for y is 260 multiplied by 5 divided by 13, because 5 in the y axis. So 260 multiplied by 5 over 13. So you get 100 Newton. So scalar notation is the F2x 240 to the right, and then F2y is 100 to the below of the y-axis. So we have the Cartesian vector notation for F1 is a negative 100i plus 173j, and F2 is equal to 240i minus 100j. So now we can determine the resultant force F1 and F2 by using we can total up the Fx component, negative 100 plus 240, and then we add the y component, 173 plus dengan negative 100. Then by using this formula, then we can get the magnitude of resultant force and also the direction angle of the final resultant force. Okay, I think that's all. That's all for this topic. I hope you can understand. I hope you really can understand for this chapter. This determines by the this force vector. The force vector we need to have by using, we're going to differentiate between the scalar and vectors. Vector have the direction and magnitude, so we can add the vector by using the parallelogram law method. If the force subjected to that point only 2, but if we have more than 2, we need to using the coplanar forces. We need to resolve the force into the x and y component. Then we are using this formula, resultant force in x component, resultant force in y component, by using this formula. Okay, that's all for this second chapter, force vector. We will continue the third chapter in equilibrium of particle after this in the next session, inshallah. Hopefully I can see you again in next time. Okay, bye bye, see you again.